All right. So I just wanted to talk about homework 18 and try and get a video out to you folks at home. Um, Yesterday in class we talked about the different congruence pairs or different congruence shortcuts, right? And so, for example, this one stands for side, 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 and you'll see in the diagram that the corresponding sides are all congruent. So if you have all three sides are congruent, then these two triangles are congruent. Then this is side, angle, side, and the being in the middle included is important. So there's a side and then an angle in the middle and then another side, and so then these triangles are congruent. Angle, side, angle. So there's two angles with an included side. These two triangles are congruent. And side, angle, angle. So a non-included side between two angles are also congruent. So you can see here's a side and two angles, and the side is not included, and those are congruent. And those are the only 4 of the 6 that we looked at yesterday that are congruent. Now, we want to be able to prove that triangles are congruent, because then we can say that corresponding parts of those congruent triangles are congruent. So we can answer questions like, are these two sides congruent, or is this angle and this angle congruent? So once we know that triangles are congruent, then we can say that all the individual parts, the angles and the sides, can also be congruent, and that becomes very helpful. Now, in order to get there and use our logic, we're going to use all of these different conjectures that we've already kind of been over, right? Sum of interior angles is 180. So it would be subtracting that. Exterior angle of a triangle equals the opposite two sides, is the sum of the opposite two sides. Opposite angles, sorry. Third angle of a triangle. So if two angles are congruent in a triangle, then the third is congruent. Vertical angles, if you remember, they're congruent. Linear pairs add to 180. Of course, when we start talking about this group is all parallel lines, right? And so corresponding angles are congruent. So these would be corresponding, right? Alternate interior angles are congruent. Alternate interior angles. And alternate exterior angles are congruent. And there may be some more that we'll review that you can kind of go back to that sheet, but we're kind of culminating all this stuff, and it's going to be really handy to have either to create a note card or have a sheet like this that you always keep handy, because you may need to remember some different stuff. Okay. So now, in last night's homework, we were asked to look at different triangles and say whether these two are congruent, for example, right? And then say determine whether the triangles are congruent and name the congruent shortcut. So these problems in the back are just the same as all of homework 17. But so looking at this one real quick, we can see that, well, we know, so we're given that these two angles are congruent and the side, right? And so now, but we also know because of vertical pairs, right, that those two angles are congruent. So then we can see that these are congruent because of angle, side, angle. Here we can see this one is also, we have an angle, a side, and an angle, angle, side, angle, right? And so we know that these two are congruent, angle, side, angle. Here we can see that we've got we've got angle, angle, side, angle, angle, side. And notice that the way these work is the adjacent side is this guy and this guy, so that's all corresponding. So that is angle, angle, side. So you're just going to look at the diagram, and that's the way all of these problems do go. You may have to you may have to use some of those properties to be able to prove those, and some of them cannot be determined. But now let's get into the meat of what we're talking about today, and that's where we're starting to get into proofs and such. So it's important, first off, to always be able to be, so we want to try and prove that AD, this is AD, is congruent to BC. And the way that we're going to do that is we're going to prove that these two triangles are congruent. And then because these are corresponding parts, right? Because B corresponds to A in this angle, right? Then we can say that those parts are congruent. So in looking at this, right, we have an angle and a side, and so the question is, can we find another angle or side that helps us out and gets to one of our shortcuts? And you notice that these two are vertical pairs, right? And so those will be our third angle, and then we can prove that these two are congruent. So AM is congruent to BM, and that's just given, right? It's given in the diagram. Angle A is congruent to angle B. That's just given. It's in the diagram. Angle 1 is congruent to angle 2 because of vertical pairs. And finally, and so then because we have an angle, and an included side, then we can say that these two triangles are congruent because of angle, side, angle. Then, because these two triangles are congruent, we can say that any corresponding parts are congruent because of corresponding parts of congruent triangles are congruent. So then we can say that these two are congruent. Cool. So let's look at the next one. So they want us to prove that AE is congruent to BD. And you can see these two we got one triangle here and one triangle there. They're kind of laid over top of us, which can be a little confusing. So to visualize my path, right? So let's see what I've got. So I've got an angle. These two angles are congruent. And these two angles are congruent. So I need to find another side or an angle, right? And so here's an angle, here's an angle. I don't know what I can say about this angle, but I notice that this side is shared by both this triangle and this triangle. So this side AB. So I'm going to say that AB is congruent to BA because it's the same segment. So then I have angle, angle, side. So I can say that these two triangles are congruent, ADB and BEA, and you'll notice that they're written so that all the parts correspond. And so then I have angle, angle, side, and so now I can say cpctc because these two triangles are congruent, so all the parts of a congruent, and AE is congruent to BD. So let's go on just a little bit more, a couple more examples, and then we'll call that good for the day. So they want us to see if these two angles are congruent. And they give us two sides. So we're either going to need to find a third side or an included angle. Okay? Because with two sides, you either have to have three sides or an included angle in between. So they give me MN is congruent to MA. And they give us ME is congruent to, so this one is congruent to this one, and this is congruent to this. Now, but you'll notice here, look, that angle is common to both. Okay, so first we'll say MN is congruent to MA, and ME is congruent to MR, and those are just given. And then we can say that angle M is congruent to angle M because it's the same angle. So then we can say that triangle, and we'll call it MAE, is congruent to triangle MNR, and so then we can say that angle E, and we know that because of side, angle, side, because I've got this long side, common angle, and then this short side. And so then we know that angle E is congruent to angle R because of cpctc. All right, let's do another little example. Now, in looking at this one, it's a parallelogram, which means, so that means that these two lines are parallel and these two lines are parallel. And because of that, that kind of opens up all of these alternate interior, alternate exterior corresponding angles, right? The other thing that's true of a parallelogram is that these sides are congruent and these sides are congruent. So there's actually two ways that we could prove that these two, because if we know that these two sides are congruent and these two sides are congruent, right? So HF is congruent to AL, and HA is congruent to FL, right, because it's a parallelogram. And then you'll notice that HL is congruent to, is common to both, so we'll say that HL is congruent to LH because it's the same segment. And then we can say that triangle FHL is congruent to, so I'm going to start up here, and I went boom, so this is congruent to this, so I'm going to say congruent to triangle ALH because of side, side, side. But what I notice here is HA to HF, those are not corresponding parts. So this cannot be determined. Now it looks like they could be the same, but we can't know that because these are not corresponding parts. Okay, my lovely handwriting here. I want to do one more example. I'm going to skip ahead to number 5 here, mainly because there's a technique that where we can draw as many lines in here as we want, right? And so right now there's no triangles, right? But I know that FO is congruent to FR, and UO is congruent to UR, right? There's no triangles there though. But what if I drew this line in here? Then this is common to, this is congruent with itself, and then we can say that this is side, side, side. So let's write that down. FO is congruent to FR. UO is congruent to UR, and those are given. And then I can say that FU is congruent to FU, or UF, because same segment. So I know that triangle FUO is congruent to triangle F, and you'll notice that I did FUO, so that's FUO, so I'm going to do FUR. Oops. FUR. And so then I can say that whatever part, so U and R, here are O and R, so angle O is congruent to angle R because of cpctc. Cool. Well, I hope those examples help you out. there is a key to answer any questions that you have, and good luck.